Hi, welcome to part 15 of the video series about laws of motion. In the previous videos, we have covered all the topics about the laws of motion required for a CAPS-aligned exam. In this one and in the upcoming videos related to the laws of motion, we are going to solve some questions to understand the topic better. In question 1, we are given two objects connected to each other by means of an inextensible string. A force of 40 newtons is applied on a 3 kg object. We are asked to calculate the tension force on the string between the objects. In laws of motion related questions, if we are given two or more objects, usually we follow the same steps. As a first step, we draw free body diagram for each object and write an equation according to the diagram. Then we solve an equation system consisting of equations we got in the previous step. By solving the equations above, we manage to calculate the acceleration of the system. As a last step, we are generally asked to substitute the acceleration in one of the equations to calculate one of the forces. Don't worry if it seems too complicated. We will try to repeat these steps in almost each of the extra questions. And hopefully, by the end of this topic, we will feel comfortable with any kind of questions about laws of motion. Now, let's start solving the given question. First, we draw free body diagram and write an equation for the 2 kg object. Forces applied on this object are force of the gravity, the normal force, and the tension force. According to the second law of motion, the net force is equal to the product of mass and acceleration. As the force of gravity and the normal force balance each other, the net force on the object is equal to the tension force. Mass of the object is 2 kilograms. We can now write the equation as tension force is equal to 2 times acceleration. This is going to be our first equation. Now we repeat the same steps for the 3 kg object. Forces applied on this object are force of gravity acting downwards, the normal force acting upwards, applied force to the right, and finally tension force acting to the left. Again, we write the second law of motion as F net is equal to mass times acceleration. The system is moving to the right, so we consider it as a positive direction. On the left side of the equation, net force is equal to the difference of the applied force and the tension force. After substitutions, 40 minus tension force is equal to 3 times acceleration. This is going to be our second equation. We have two equations now. Let's solve an equation system for these two equations. In equation 1, t is equal to 2 times acceleration. In equation 2, 40 minus t is equal to 3 times acceleration. We have two equations with two unknowns, tension force and acceleration. Even though it's possible to calculate the value of tension force from these two equations, it's not always the shortest way. Thus, we will first calculate the acceleration. We can substitute tension force in the second equation with 2 times a. Acceleration of the system is equal to 8 meters per second square. Now we can substitute the acceleration in one of the equations. It's not important which one will we use. The answer will be the same. For this question, let's use the first equation. Tension force is equal to 2 times acceleration. 2 times 8 is equal to 16 newtons. In this video, we have learned how to calculate the tension force on the string between two objects. While doing it, we have ignored the friction force. In the next video, we will solve similar question, but this time we will consider the friction force too. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.